UNESCO did not say a Mediterranean tsunami is possible. It said it is inevitable, and that single word changes everything. Because this is not an empty ocean. This is the sea beside Europe's beaches, cruise ports, island resorts, ancient cities, airports, and packed summer coastlines. Beneath the blue water, fault lines are locked, volcanoes are unstable, and underwater slopes are waiting to fail. In some places, the wave may arrive in minutes. No long warning, no time to debate, no second chance. So why is almost no one prepared? Which countries are most exposed? And what happens when the sea finally moves? The warning that was not a countdown. On a clear morning along the Mediterranean coast, the sea does not look dangerous. It lies flat against the stone edges of old ports, moves quietly beneath ferry ramps, and folds itself around cities that were built for trade, tourism, fishing, empire, and escape. In Marseille, it presses against the breakwaters. In Alexandria, it reaches the old Corniche. In Istanbul, it moves through one of the narrowest and most strategically watched waterways on Earth. Nothing in that surface announces catastrophe. That is why the UNESCO warning matters. Not because UNESCO announced a 9-day countdown. It did not. Not because European governments have confirmed a present panic. They have not. The real warning is colder than that, and more difficult to dismiss. The Intergovernmental Oceanographic Commission of UNESCO states that there is a 100% chance of a tsunami at least 1 metre high occurring in the Mediterranean within the next 30 to 50 years. That detail matters because the danger is not measured only by wave height. It is measured by warning time, coastal density, tourist behaviour, and whether people know where to go when the water begins to move. The Mediterranean is not the Pacific. It is smaller, more enclosed, more crowded, and in many places more deceptive. A tsunami generated near Japan or Chile may cross open ocean for hours before reaching distant coasts. A tsunami generated inside the Mediterranean can arrive in minutes, in a basin surrounded by earthquake zones, volcanic islands, steep underwater slopes, ancient ports, cruise terminals, beaches, petrochemical plants, and summer towns that multiply in population during holiday season. The clock is not generous. This is the part of the warning that often gets lost. UNESCO was not describing a single wave already on its way. It was describing a probability locked inside geology. The African plate continues to push northward. The Eurasian margin continues to deform. Fault systems beneath the Alboran Sea, the Hellenic Arc, the Calabrian region, the Aegean, and the waters around Turkey do not need public attention in order to keep accumulating strain. The sea looks still because the process is slow. The release, when it comes, is not. After the Indian Ocean tsunami of December 26, 2004, the world built systems it should have built earlier. More than 200,000 people died across 14 countries, and one of the clearest lessons was that detection, without public readiness, is only half a warning. UNESCO's tsunami program grew out of that failure, expanding regional warning and mitigation systems beyond the Pacific into the Indian Ocean, the Caribbean, and the northeastern Atlantic and Mediterranean region. The Mediterranean system is called NIMTWS, and its purpose is not to predict the exact day. Its purpose is to shorten the silence between seabed movement and human response. The question is why this warning now feels different. Part of the answer is geography. The Mediterranean coastline is one of the most heavily inhabited coastal systems in the world. It contains ancient cities that predate modern hazard maps and modern resort towns, built for access to the water, not retreat from it. A beach promenade that functions beautifully on an ordinary summer evening can become a trap when evacuation has to happen on foot. Roads near the shoreline are often narrow. Parking is often dense. Visitors often do not speak the local language. Warning signs, if they exist, may be missed until they are needed. The other part is time. Italy's Civil Protection Department states the central problem directly. In a relatively small sea such as the Mediterranean, wave arrival times can be short, reducing the time available to alert the population. Italy also notes that every Mediterranean coast is exposed to tsunami risk because of seismicity and active volcanoes, including emerged and submerged volcanic systems. That is not a prediction of destruction everywhere. It is a recognition that the basin itself is structurally capable of producing dangerous waves. Hold that thought, because this is where the title version of the story and the scientific version of the story separate. A headline can say Europe is in panic. A preparedness document will say something more useful. It will say hazard zones must be mapped. It will say evacuation routes must be marked. It will say communities must practice before the day arrives. It will say a siren is not enough if a tourist does not know whether to run inland, climb upward, or wait for confirmation. In a local tsunami, waiting for confirmation can be the mistake. That is why UNESCO's Tsunami Ready program exists. To qualify, communities must build risk reduction plans, map hazardous areas, prepare public education material, create evacuation maps, display tsunami information, and conduct exercises. These are not dramatic measures. They are administrative, repetitive, and easy to overlook. But in disaster history, the ordinary measures are often the ones that separate survivable events from mass casualty events. Cannes became the first UNESCO IOC tsunami-ready community in mainland France and the northeastern Atlantic and Mediterranean region in January 2024. The city's recognition was not symbolic tourism branding. It reflected alert systems, hazard assessments, evacuation mapping, signage, drills, education materials, and formal coordination. Cannes also identifies two different time windows, 15 to 30 minutes for a local phenomenon such as an earthquake or underwater landslide, and 60 to 100 minutes for an earthquake off North Africa. The difference between those two scenarios is the difference between an evacuation and a race. Spain offers another clue. In Chipiona, near Cadiz, evacuation routes are signposted and drills are conducted each November, timed to remember the Lisbon earthquake of November 1st, 1755. Malaga, farther east along the Costa del Sol, faces a different geometry. A tsunami from the Alboran Sea could reach parts of the coast in about 20 minutes, according to tsunami modeller Jorge Macias of the University of Malaga. That becomes important later, because 20 minutes is not a comfortable margin. It is barely enough time for confusion to become movement. The significance of the UNESCO warning, then, is not that a wave has been dated. It is that the Mediterranean has been placed inside a deadline measured in preparedness, not prediction. 30 to 50 years sounds distant until it is compared with how long cities take to change signs, train staff, revise port procedures, educate schools, redesign evacuation routes, and persuade tourist economies to discuss a hazard they would rather not advertise. This is the central tension. The sea is calm most days. The risk is real every day. The public wants a date. The science gives a probability. Governments want certainty before they spend money. The geology gives strain, faults, slopes, volcanoes, and records of older waves. A 1-meter tsunami does not sound like a wall from a disaster film, but tsunami waves carry energy differently from wind waves. They can push inland as moving water, lift vehicles, flood streets, damage ports, and turn familiar waterfronts into channels. The Mediterranean does not need to produce the largest tsunami in history to expose its weakness. It only needs to produce one close enough to shore, fast enough after an earthquake, and aimed at a coastline that has not practiced what to do. That is the warning. Not 9 days, not panic. A basin full of beautiful coastlines has entered the part of the story where preparation is no longer theoretical. The fault lines beneath the holiday coast. The Mediterranean does not begin as a disaster zone. It begins as postcards. White balconies over blue water, ferries leaving behind slow white wakes, fishing boats tied to concrete quays, hotels facing beaches arranged for stillness, not evacuation. In Nice, morning light reaches the Promenade des Anglais before most visitors understand the shape of the land behind them. In Malaga, the coast stretches between mountains and the Alboran Sea. In Crete, cliffs and harbours sit above one of the most dangerous tectonic margins in Europe. The danger is not visible at the surface. It is drawn beneath the water where the Mediterranean is being compressed by continents that are still moving. Africa is not simply below Europe on a map. Geologically, it is pushing north. Eurasia is resisting. Between them, the seafloor bends, fractures, slides, and locks. The Hellenic arc curves south of Greece and Crete. The Calabrian region sits between Sicily and mainland Italy. The Alboran Sea lies between southern Spain and northern Morocco. Each zone is different, but together they explain why the Mediterranean is not a quiet basin. It is a squeezed basin. That detail matters because tsunamis do not require open ocean size to become lethal. They require displacement. A section of seabed must move water suddenly. An earthquake can do it if the fault motion lifts or drops the seafloor, A submarine landslide can do it if sediment collapses downslope. A volcanic flank can do it if enough rock enters the water. The Mediterranean contains all three mechanisms. UNESCO's own regional warning framework identifies the northeastern Atlantic and Mediterranean as a tsunami risk region because of seismic and volcanic activity, dense coastal settlement, and the possibility of both small and destructive events. The Hellenic Arc is the first place to look. It runs from the Ionian side of Greece past Crete and toward Rhodes, marking one of the most active seismic zones in the region. Along this margin, the African plate descends beneath the Aegean microplate. The geometry is not simple. It is folded by trenches, back arc extension, crustal blocks, and faults that do not always behave in the same direction. But the consequence is clear. Large earthquakes have occurred here before, and several Mediterranean tsunamis are linked to the waters around Crete and the Aegean. On July 21st, 365 before sunrise, a major earthquake near Crete generated one of the most studied ancient tsunamis in the Mediterranean record. Researchers still debate parts of the rupture and the full extent of its impact, but the event is widely associated with severe tsunami effects across parts of the eastern Mediterranean. Alexandria remembered it for centuries as a day of horror. In western Crete, evidence of sudden coastal uplift has helped geologists understand the scale of the event. The point is not that the past will repeat itself exactly. It is that the basin has already demonstrated the mechanism. Move west, and the pattern changes without disappearing. Around Sicily and Calabria, the threat is not only one great subduction-style rupture. It is a crowded tectonic knot of normal faults, steep slopes, volcanic systems, and narrow channels. At dawn on December 28, 1908, an earthquake struck the Strait of Messina between Sicily and Calabria. Messina and Reggio Calabria were devastated, and a tsunami followed, sending waves into nearby coasts. Britannica describes waves estimated at about 13 metres and more than 80,000 deaths from the combined disaster. The source of the tsunami remains debated, with both fault displacement and submarine landsliding discussed. That uncertainty matters. It means the sea can respond to more than one kind of failure. Farther west, the Alboran Sea looks smaller on a map, almost like a narrowing before the Atlantic. It is not small in consequence. Between Spain and North Africa, crustal blocks rotate, and fault systems absorb the collision between Africa and Eurasia. Southern Spain is not famous internationally as a tsunami coast in the way Japan or Indonesia are, but researchers and civil protection planners increasingly treat the Alboran as a near-field tsunami source. In Malaga, a tsunami from a nearby Alboran source could arrive in roughly 20 minutes. 20 minutes is not a comfortable warning. It is the time it takes a crowded beach to misunderstand a siren, find children, hesitate at a road crossing, and lose the margin. The question is why these margins are so difficult to communicate. Part of the problem is that Mediterranean tsunamis are infrequent on a human schedule. A city can go through generations without one. Buildings rise, harbours expand, beach economies grow, apartment towers fill the low ground because the low ground is valuable. Memory thins faster than risk disappears. By the time the next event becomes geologically likely, the last one has become history, and history is easier to frame as something finished. Another problem is that earthquake shaking and tsunami danger do not always align in the public mind. If the coast shakes violently, people may understand the need to move, but not every tsunami source produces severe local shaking at every threatened shore. A submarine landslide can send water outward without giving the same warning felt by a person standing on a promenade. A distant regional earthquake can produce a wave that arrives after the shaking has been forgotten or never felt. Even a small tsunami can become hazardous inside a harbour, where basins amplify motion and currents rip through moorings and narrow entrances. The Mediterranean is full of those harbour spaces. Old ports were built where the sea was useful, not where evacuation was easy. Modern cruise terminals, marinas, container areas, waterfront restaurants, and seaside roads often occupy the same edge. In a near-field tsunami, the first operational problem is not scientific detection. It is human behaviour. Who receives the alert? Who trusts it? Who moves first? Who waits for confirmation? Who assumes the sea must withdraw before danger arrives, even though not every tsunami begins with that visible sign? This is why UNESCO's language has become sharper. The organisation is not saying that one fault has scheduled a catastrophe. It is saying that the Mediterranean contains enough known sources, enough historical precedent, and enough exposed coastal population that a damaging tsunami is statistically inevitable within planning horizons. The difference is important. Prediction asks for the day. Preparedness asks what happens when the day is unknown. Along the holiday coast, the machinery remains hidden. Beneath ferries, beaches, resort piers, fishing grounds, and old naval roads, the plates continue their slow contact. The Hellenic arc stores strain. Sicily and Calabria sit inside a complex zone of faults and submarine slopes. The Alboran Sea holds sources close enough to give cities almost no time to think. The Mediterranean is beautiful because people built beside it for thousands of years. It is dangerous for the same reason. The cities that have only minutes. A tsunami warning does not arrive first as a wave. It arrives as a decision made inside a room most people will never see. A seismometer records movement. A pressure sensor may register disturbance. A duty officer watches numbers appear on a screen. Software compares epicenter, depth, magnitude, and source geometry against pre-modelled scenarios. Then a message moves through institutions faster than any person on a beach can interpret the sea. That is the ideal version. The Mediterranean version is harsher because the distances are short. In a relatively small sea, wave arrival times can be so compressed that authorities may have little time to issue an alert before water reaches exposed coastlines. Italy's Civil Protection Department states this plainly. Short arrival times reduce the time available to alert the population, and every Mediterranean coast is exposed to tsunami risk because of seismicity and active volcanoes in the region. The warning chain exists, but the geography limits it. Picture a summer afternoon in Cannes. The waterfront is crowded. The city sits along about 15 kilometres of coastline when the leaden islands are included. Hotels face the water. The old port, beaches, festival venues, marinas, restaurants, buses, delivery vehicles, and visitors occupy the same narrow strip between the sea and the rising land. On January 19, 2024, Cannes was recognised as the first UNESCO IOC tsunami-ready community in mainland France and in the northeastern Atlantic and Mediterranean region. That did not mean the city was safe from a tsunami. It meant the city had begun treating the hazard as operational rather than theoretical. Operational risk means signs must exist before panic exists. Routes must be known before the crowd forms. Schools, hotels, police, harbour staff, emergency managers and residents must understand the same basic instruction before the siren ever sounds. Tsunami-ready communities are expected to map hazard zones, prepare evacuation plans, conduct exercises, place public information where people can see it, and keep alert mechanisms functioning. The work is administrative, but the purpose is physical. It's about moving bodies away from water faster than water can move toward them. The question is whether a coastal city can do that in 15 minutes. In Cannes, local planning distinguishes between different tsunami sources. A local phenomenon, such as an earthquake or underwater landslide, could leave roughly 15 to 30 minutes before impact. A source farther away, such as an earthquake off North Africa, could offer 60 to 100 minutes. Those numbers are planning ranges, not fixed promises. But the difference between them is the difference between a structured evacuation and a forced improvisation. 15 minutes is not enough time to debate whether the alert is serious. 15 minutes is barely enough time to stop filming the water and start climbing. The same problem appears on the Spanish side of the Western Mediterranean. In Chipiona, near Cadiz, tsunami preparedness has become visible in the streets. Evacuation signs point away from the low coastline. Sirens have been tested, drills are held. The town's memory is shaped partly by the Lisbon earthquake of November 1st, 1755, a catastrophe that sent waves across the Gulf of Cadiz and into Atlantic-facing coasts. Chipiona has been recognised through UNESCO's Tsunami-Ready framework, and the point is not to predict the next Lisbon-scale event. It is to make sure that residents and visitors do not spend the first minutes looking for instructions. Malaga is a different image. The city opens toward the Alboran Sea, where the boundary between Africa and Eurasia is not an abstraction, but a nearby source. Behind the beaches are roads, apartments, rail links, hotels, and the infrastructure of an urban coast. A tsunami generated in the Alboran Sea could reach parts of the Costa del Sol in about 20 minutes, according to tsunami modeller Jorge Macias of the University of Malaga. 20 minutes sounds longer than it is. In that time, an official alert must be processed, passed through emergency systems, received by the public, believed by the public, and converted into movement. Any one failure narrows the window. This is the last mile problem. Detection may be scientific, survival is social. A warning centre can identify a threat, but it cannot force a family to leave a beach, clear a waterfront road jammed with cars, translate a siren into 6 languages, or make a hotel guest know where higher ground is. It cannot stop people from walking toward a harbour because the water has pulled back. That detail matters because the Mediterranean is a tourist basin. Its most exposed populations are not always registered residents. They are seasonal workers, cruise passengers, day visitors, beachgoers, yacht crews, restaurant staff, and families who arrived that morning. A city may have a civil protection plan, but the people most at risk may not know it exists. The hazard is local. The population is temporary. The alert must travel across that mismatch in minutes. Italy shows the same tension in a different form. The country has a national tsunami warning centre operated by the Istituto Nazionale di Geofisica e Vulcanologia as part of the wider Mediterranean warning system. Its exposure includes Sicily, Calabria, the Tyrrhenian coast, the Adriatic, volcanic islands, steep submarine slopes, and old towns built at the water's edge because that was where commerce happened. Italy's guidance emphasises that natural warning signs still matter, including strong shaking, rapid sea withdrawal, or unusual sea movement. The historical record makes that warning less abstract. In 1908, Messina and Reggio Calabria were struck by a devastating earthquake and tsunami. In 1979, near Nice, a landslide associated with airport works and submarine slope failure generated a local tsunami along the French Riviera, killing 8 people and causing severe coastal impacts. The Nice event is especially important because no great offshore earthquake was required. The source was local, the coast was close. The lesson was not that the Mediterranean only produces Pacific-style disasters. It was that small basins create small warning windows. What happened next in European planning was slow, uneven, and easy to miss. Some towns installed signs, some ran drills, some entered UNESCO's readiness framework. Some remained quiet because visible tsunami preparation can feel uncomfortable in places built on the promise of safety and leisure. A hazard sign near a beach does not help sell the beach, but it may save the person standing on it. That is the problem facing the Mediterranean coast now. The science has moved from possibility to probability. The warning systems have improved, the hazard maps are becoming sharper, but the real test is not whether a sensor can detect the first rupture. The real test is whether a crowded waterfront can become an evacuation route before the first wave reaches the street. The tsunami Europe already forgot. Europe remembers earthquakes as ruined walls. It remembers fire as smoke above a city. It remembers war through monuments, plaques, cemeteries, and names carved into stone. Tsunamis are harder to remember. They do not leave a single standing object that explains them. They arrive, tear through the low ground, drag boats across streets, fill churches and warehouses with mud, then retreat into the same sea that tourists return to a generation later. That is the problem with the Mediterranean warning. The hazard is not new, the memory is. On the morning of November 1st, 1755, Lisbon was already awake. It was All Saints' Day, and churches were full of candles. The city stood as one of the great imperial capitals of Europe, tied by money, religion, empire and Atlantic trade to Brazil, Africa and India. Then the ground began to move. Modern estimates place the earthquake at roughly magnitude 8.5 or higher, though exact values remain uncertain because the event occurred before instrumental seismology. Buildings collapsed across Lisbon. Fires began in the city. Then the sea withdrew and returned as a tsunami. The waves struck Portugal, Spain, Morocco, and were recorded across parts of the Atlantic. The significance of that disaster was not only the number of dead, though the death toll was enormous and remains historically uncertain. It was the way the event broke Europe's sense of order. A city of churches was destroyed during a holy day. Philosophers, priests, engineers, and political leaders argued over what the catastrophe meant. The Marquis of Pombal, Sebastião José de Carvalho e Melo, became central to the reconstruction of Lisbon and to the early systematic collection of earthquake reports. The disaster helped push European thinking towards seismology, urban planning, and state-led emergency response. but the tsunami itself slowly became secondary in popular memory. The earthquake remained, the wave faded. That detail matters. When people forget the wave, they forget the shoreline. The 1755 tsunami did not belong only to Lisbon. Along the Gulf of Cadiz and the Atlantic-facing coasts of Iberia and Morocco, the ocean moved violently enough to enter local memory. In Spanish coastal planning today, that event still appears as a benchmark for worst-case thinking. Chipiona, near Cadiz, has used tsunami drills and visible evacuation signs as part of its preparedness, with the Lisbon catastrophe functioning not as folklore, but as a reminder that the southwestern Iberian coast has already been reached by a major tsunami. The question is why a known historical disaster does not automatically produce modern readiness. The answer is that history competes with land value. Waterfronts are rebuilt because waterfronts are useful. Ports must function. Beaches attract money. Promenades become civic identity. Hotels, roads, restaurants, apartments, and parking lots occupy the same ground where water once moved, because daily life has a stronger claim than rare catastrophe. A tsunami return period measured in centuries is difficult to govern against when elections, tourist seasons, and construction permits move in years. More than 150 years after Lisbon, the Mediterranean produced another warning, this time inside one of Europe's most dangerous narrow passages. Before dawn on December 28, 1908, the Strait of Messina between Sicily and Calabria shook violently. Messina and Reggio Calabria were devastated. A tsunami followed, sending waves estimated at up to about 13 metres against parts of the coast. Britannica records more than 80,000 deaths from the combined earthquake and tsunami disaster. The setting made the disaster worse. The strait is narrow, populated, and framed by steep terrain and coastal settlements. People lived close to the water because that was where trade, fishing, transport, and urban life had concentrated for centuries. When the earthquake struck, buildings failed first. The tsunami entered a landscape already broken. Survivors who had moved toward the shore after the shaking could find themselves exposed to the next phase of the disaster. In later scientific work, the precise tsunami source remained debated, with researchers considering fault displacement and submarine landsliding as possible contributors. That uncertainty is not a weakness in the story, it is the lesson. In the Mediterranean, more than one process can make the sea rise. The Messina catastrophe should have become the permanent European warning. In some technical circles, it did. It remains a reference event in Italian hazard planning and tsunami science. But outside those circles, the disaster became a historical tragedy rather than a living coastal instruction. The cities were rebuilt. Migration carried survivors elsewhere. Memory became architectural, then archival. The strait continued to fill with ferries, roads, homes, and port activity. The sea resumed its ordinary appearance. Then came Nice. On October 16, 1979, the French Riviera was not expecting a classical earthquake tsunami. Near Nice-Côte d'Azur Airport, construction and reclaimed land were part of a coastal expansion project. A section failed and collapsed into the sea, triggering a submarine landslide and a local tsunami. Scientific studies describe deaths and major material damage. Other summaries identify at least 8 people killed. The event damaged the coast and revealed something deeply uncomfortable. A tsunami could be produced not by a famous offshore earthquake, but by local slope failure near a modern infrastructure project. That becomes important later, because the French Riviera is not remote. It is one of the most developed and recognizable coastlines in Europe. Nice, Antibes, Cannes, and surrounding towns are associated with airports, festivals, beaches, marinas, and dense seasonal population. The 1979 event showed that the danger did not need ancient mythology or distant subduction zones. It could come from the geometry of a continental slope, unstable sediment, human construction, and gravity. The wave did not need to cross an ocean. It only needed to cross a short distance. This is the common thread linking Lisbon, Messina, and Nice. Each event entered the record through a different mechanism and scale. Lisbon was a vast Atlantic earthquake and tsunami. Messina was a catastrophic strait disaster, involving earthquake shaking and tsunami impact. Nice was a local landslide-generated tsunami on a modern coast. Together, they dismantle the comforting idea that European tsunamis are too rare, too distant, or too small to matter. UNESCO's current warning sits on top of that record. The Intergovernmental Oceanographic Commission states that there is a 100% chance of a tsunami at least 1 metre high in the Mediterranean within the next 30 to 50 years, and identifies the wider northeastern Atlantic and Mediterranean region as exposed because of seismicity, volcanic activity, and dense coastal settlement. The old disasters are not being remembered because they are dramatic. They are being remembered because they describe the same weakness in 3 different forms. The coast is where people gather, the sea is where the hazard hides. The interval between events is long enough for confidence to return and short enough, in geological terms, to be dangerous. Europe did not forget that tsunamis happened. It forgot to behave as though they can happen again. The sea that gives almost no warning. A tsunami warning begins before the sea changes. It begins in motion too small for a person standing on a pier to recognise. Somewhere beneath the basin, rock slips. The first record may be a sharp signal on a seismometer, a line jumping inside a national monitoring centre while the coast remains ordinary. The gulls keep moving over the harbour. Restaurant chairs stay stacked on the pavement. Ferries idle with engines low and steady. The surface gives almost nothing away. Inside the warning chain, the first question is not whether the event is frightening. It is whether it is tsunami-genic. The earthquake must be located. Its magnitude must be estimated. Its depth must be judged. Its relationship to the sea must be understood quickly enough to matter. In the Mediterranean and the northeastern Atlantic, tsunami bulletins are supplied through the regional system by candidate service providers in France, Greece, Italy and Turkey, with official warnings passed through national authorities rather than directly by UNESCO to the public. That distinction matters because the science may be regional, but the order to evacuate is national and local. In France, the Centre d'Alerte aux Tsunamis, known as CENALT, watches strong earthquakes and tsunamis in the western Mediterranean and the northeast Atlantic. Its public description is precise. It monitors these events and alerts civil protection when tsunami risk exists. The centre is not a siren on a beach. It is the upstream part of a chain that must pass from instruments to analysts, from analysts to authorities, and from authorities to the exposed ground where people are standing. That chain can be fast and still feel late. The Mediterranean compresses time in a way that the Pacific does not. A distant Pacific tsunami can take hours to cross open ocean. A Mediterranean event can begin close to the coast that it threatens. When the source lies offshore, near an island arc, a volcanic flank, or a submarine slope, the warning centre may still be calculating while the first harbour currents are already changing. The sea does not wait for administrative certainty. The technical system is larger than one country. UNESCO IOC describes regional tsunami warning systems as end-to-end systems involving data sharing, monitoring, warning dissemination, and public learning. Sea level stations transmit observations every few minutes through geostationary satellites into the global telecommunication system of the World Meteorological Organization, where they can be used by warning centers and sea level institutions. This is the invisible architecture behind the message that eventually reaches a phone, a port office, or a civil protection desk. But the phrase end to end can be misleading if it sounds complete. The end of the system is not a computer. It is a person deciding to move. It is a hotel receptionist telling guests to leave the lobby. It is a harbour master ordering boats to stop trying to save property. It is a teacher choosing the nearest route to higher ground before parents start calling. In a near-field event, the final meters of the warning chain are human, crowded, and imperfect. Turkey's Kandilli Observatory and Earthquake Research Institute shows how complex that chain has become. Its tsunami warning system for the eastern Mediterranean, Aegean, Marmara and Black Seas was established under the UNESCO IOC NIMTUS framework, after preparatory work between 2009 and 2011. It entered operational status as a candidate tsunami warning centre on July 1st, 2012, alongside CENALT in France, with Greece, Italy and Portugal later joining the regional coverage. The system has improved, but researchers involved with COERI have still emphasised that the tsunami warning chain is not fully complete at national or international level, and that every minute counts. The significance of that admission is easy to miss. It does not mean the system has failed. It means the problem is bigger than detection. A warning centre can issue a technically correct message and still lose lives if the downstream system is slow, unclear, mistrusted or unfamiliar. Sirens can be unheard behind hotel glass. Text alerts can arrive in a language the visitor does not read. A coastal road can become a parking lot within 3 minutes if everyone chooses the same direction. A person can see the sea pulling back and walk closer because the exposed seabed looks impossible. That behaviour has happened before in tsunamis around the world. The Mediterranean cannot assume it is immune to it. In places where damaging tsunamis are rare, ordinary people do not carry mental rehearsals. They carry beach routines. They know where the cafe is, where the restroom is, where the car is parked, and where the children left their shoes. They may not know the blue and white evacuation sign. They may not know that the safest move is inland and upward. They may not know that the first wave may not be the largest. Sinalt's public explanation of tsunami generation states that tsunamis can be produced by shallow underwater or coastal earthquakes, with stronger earthquakes capable of generating basin-wide destructive waves. That is the clean scientific description. The messier social description is that a basin-wide wave enters a coastline built by centuries of habit. Old ports were designed to receive the sea. Promenades were designed to enjoy it. Resorts were designed to approach it. None of those designs begin with the assumption that the sea must suddenly be fled. The warning system therefore has 2 clocks. The first clock belongs to the instruments. It starts when the fault breaks and runs through detection, modelling and official messaging. The second clock belongs to the public. It starts when a person understands that the warning is for them. In a well-prepared town, the 2 clocks nearly overlap. In an unprepared town, they can separate fatally. The message may exist, but the movement does not. That is why drills matter. That is why signs matter. That is why UNESCO's preparedness work focuses not only on sensors, but on communities capable of responding before certainty becomes visual. Once the water is visible in the street, the warning has already become evidence. The purpose of the system is to make people act while the sea still looks normal. This is the uncomfortable truth beneath the Mediterranean warning. Europe is not facing a lack of science. It is facing a race between science and behaviour. The sensors can detect. The centres can calculate. The authorities can alert. But if the first minutes are spent verifying, filming, arguing, packing or driving along the coast instead of leaving it, then the most advanced warning architecture in the basin has reached the human end of the chain and slowed there. The sea gives almost no warning. The system must give the rest. The coastline built in the wrong place. The Mediterranean coast was not built with retreat in mind. It was built for arrival. Ships came first, then warehouses, then markets, then customs houses, churches, rail lines, roads, hotels, airports, apartment blocks, marinas, restaurants, cruise terminals, and beaches arranged into economies. For thousands of years, the edge of the water was not treated as a danger line. It was treated as the reason the city existed. That is why the tsunami problem is not only geological, it is architectural, it is economic, it is historical. The exposed coastlines of the Mediterranean were not placed there by accident. They were placed there because the sea made them valuable. In Barcelona, Marseille, Naples, Palermo, Cannes, Malaga, Heraklion, Alexandria, and countless smaller towns between them, the waterfront is not an empty zone that can be cleared by a technical order. It is where the city concentrates itself. A warning map may mark the low ground in colour, but the low ground is also where the ferry terminal stands, where the old port operates, where visitors gather at sunset, where the most expensive rooms face the water, and where delivery trucks move before dawn. The hazard zone is not outside daily life. It is daily life. The Mediterranean Expert Network on Climate and Environmental Change has warned that coastal risks are being intensified by urbanisation, climate change, erosion, flooding, and growing exposure along Mediterranean shorelines. Its coastal risk work does not focus only on tsunamis, but the underlying lesson is the same. The coast has become more crowded, more valuable, and more fragile at the same time. That detail matters because tsunami planning does not begin on the day of a tsunami. It begins with what has already been built where the water can go. Look at the French Riviera, where the hills fall close to the sea and the built coast has very little spare space. Roads squeeze between cliffs, villas, rail lines, airports, and beaches. Nice Côte d'Azur airport itself sits on reclaimed coastal land, projecting into a zone where the continental slope drops beneath the water. On October 16, 1979, Part of the new harbour construction associated with airport expansion collapsed into the sea. Scientific studies describe a catastrophic event on the Nice continental slope that caused loss of life and major material damage. A later synthesis of the Nice airport tsunami describes a local origin tsunami that struck the French Riviera, killing 8 people and generating important economic losses. The point is not that every airport, port or marina is unsafe. The point is that the modern Mediterranean coast has repeatedly pushed infrastructure toward the edge because the edge is profitable and useful. Land beside the sea is scarce. Reclaimed land looks like a solution. Harbour expansion looks like progress. A runway near the water shortens access to tourism. A marina transforms a shoreline into revenue. But the sea does not evaluate those choices as investments. It evaluates them as geometry. That becomes important later, because tsunami impact is shaped by geometry. A low harbour can funnel currents. A narrow bay can amplify water motion. A promenade can become a flow path. Underground parking, coastal underpasses, basements, and marina service areas can fill quickly. Beaches stripped of dunes and wetlands lose natural buffers, while hard seawalls may protect against ordinary waves without solving the problem of fast-moving inundation. Along parts of Spain's southern coast, reporting on tsunami readiness has noted that extensive coastal development has removed natural barriers such as dunes and wetlands, leaving parts of the shore more exposed when extreme water arrives. There is a quiet contradiction here. The Mediterranean sells proximity to the water. Tsunami safety requires distance from it. Tourism economies teach people to move closer, book the sea view room, eat at the waterfront table, walk the harbour wall, take the photograph from the pier, stay near the beach. Emergency planning asks the same person to reverse that instinct instantly. The danger is not ignorance alone, it is habit. A visitor in a coastal town does not arrive thinking in evacuation zones. He arrives thinking in routes from the hotel to the beach to the restaurant, from the restaurant to the parked car. A cruise passenger may know the name of the port but not the name of the hill behind it. A seasonal worker may know the quickest way to the kitchen entrance but not the nearest tsunami assembly point. A child may know where the ice cream stand is and not know that a blue evacuation sign means inland and upward. This is how an exposed city becomes dangerous even when the hazard map is correct. Cultural heritage deepens the problem. Many Mediterranean historic sites are coastal because ancient power was coastal. Ports, fortifications, harbours, religious buildings, archaeological remains, and old trading quarters sit low because ships once defined political life. Climate Adapt summarises research on Mediterranean UNESCO World Heritage Sites and notes that out of 49 cultural sites located in low-lying coastal areas of the Mediterranean, 37 are already at risk from a 100-year flood and 42 from coastal erosion. That study is about flooding and erosion under sea level rise, but it reveals the same pattern that tsunami planners must confront. The cultural memory of the region is physically concentrated at the water's edge. In older cities, relocation is not a simple policy. You cannot move a medieval harbour uphill. You cannot shift an archaeological waterfront inland without destroying the reason it matters. You cannot evacuate a historic district by redesigning it as if it were a modern grid. The streets may be narrow, the buildings may be protected, the access roads may already fail under ordinary tourist traffic. The built environment carries centuries of decisions that were made before tsunami science, before civil protection modelling, before mobile alerts, and before mass tourism multiplied the number of people standing near the water. The same trap appears in modern resort zones, but for different reasons. There, the problem is not ancient inheritance, it is recent confidence. Apartment towers, beachfront hotels, private beach clubs, parking lots, and commercial strips often occupy low, flat land because low, flat land is easy to sell and easy to use. A hazard that may not occur for decades becomes abstract, compared with a project that can open next summer. This is why UNESCO's preparedness language is so practical. It does not ask coastal communities to become afraid of the sea. It asks them to become organised around the possibility that the sea may stop behaving normally. Tsunami-ready standards require hazard zone mapping, evacuation planning, signage, public awareness, exercises, and alert procedures. These measures are not dramatic because the real enemy is not drama. The real enemy is the moment when a crowded waterfront has no shared instruction. The Mediterranean coast was built in the wrong place only if judged by the rare hour when water moves inland. For every ordinary day, it was built exactly where human beings wanted it, beside trade, light, fish, ships, beauty, and money. That is what makes the risk so difficult. The danger zone is also the dream zone, and when the warning finally comes, the first obstacle will not be the wave. It will be everything people built because they believed the calm sea was permanent. The volcanoes under the blue water. The Mediterranean volcano does not always look like a mountain. Sometimes it's a black cone above the sea, smoking in the distance while ferries pass with tourists on the deck. Sometimes it is an island ringed by white villages and cruise ships. Sometimes it is not visible at all, because the crater is underwater, hidden beneath a surface that looks calm enough for fishing boats and swimmers. That is where the tsunami problem becomes more complicated. Earthquakes are the obvious source. A fault breaks, the seabed shifts, and water is displaced. But volcanic tsunamis do not always follow that clean sequence. They can begin when a flank collapses. They can begin when a pyroclastic flow enters the sea. They can begin when an underwater explosion pushes water outward. They can begin when a caldera floor drops, when a landslide moves down a submarine slope, or when volcanic debris enters the water with enough speed and volume to transfer its force into a wave. The source may be small compared with a great subduction earthquake, but the coast may be close. In the Mediterranean, closeness is often the danger. Stromboli is the island that makes this clear. It rises from the Tyrrhenian Sea north of Sicily, part of Italy's Aeolian Islands, and has been famous for persistent explosive activity for centuries. At night, the volcano can glow above the water, producing the kind of visible eruption that once served as a natural lighthouse for sailors. But the real tsunami concern at Stromboli is not only the explosion at the summit. It is the unstable flank known as the Sciara del Fuoco, a steep scar on the northwestern side of the island where volcanic material can move downslope toward the sea. On December 30th, 2002, 2 landslides occurred on Stromboli's northwestern flank and generated tsunamis that struck the island's coast. The Smithsonian's Global Volcanism Program describes 2 landslides at 13:15 and 13:22 local time, with the first estimated at roughly 6 million cubic meters of rock and the second at roughly 5 million cubic meters. The waves damaged coastal areas and became one of the most important modern European examples of a landslide-generated volcanic tsunami. That detail matters because no ocean-wide rupture was required. The source was local. The failure was fast. The water had only a short distance to travel. A person on the shore would not have had the luxury of a distant ocean warning. The event demonstrated the specific Mediterranean problem in miniature: a steep island, unstable volcanic material, dense human presence near the water, and a wave generated close enough that the warning window shrinks into minutes. Stromboli did not stop teaching after 2002. A 2024 Nature Communications study reported that small tsunamis, less than or equal to 1 meter, were generated by pyroclastic density currents associated with violent explosions at Stromboli and recorded in near-source conditions within about 1.6 kilometers. The importance of that finding is not the size of the waves alone, it is the mechanism. Even relatively small volcanic processes can generate measurable tsunami waves close to the source. The question is why this matters beyond one island. The answer lies east, in the Aegean. Santorini is one of the most photographed places in Europe, but its beauty is built around a volcanic wound. The island group forms the rim of a flooded caldera, the result of repeated volcanic activity along the Hellenic volcanic arc. White towns sit high above cliffs. Cruise ships enter the caldera. Tourists look out over water that fills the space where explosive geology once removed the centre of the island. The setting is peaceful, only because human time is short. The late Bronze Age eruption of Santorini, often called the Minoan eruption, remains one of the most studied volcanic events in Mediterranean archaeology and geology. Its exact date and wider historical consequences are still debated, but its scale is not treated casually. Tsunami evidence linked to the eruption has been identified in northern Crete. A 2021 scientific report study described a tsunami deposit west of Malea and concluded that a tsunami related to the Bronze Age Santorini eruption reached the outskirts of the palatial centre, with local inundation up to 400 metres inland. The significance of that discovery is not that every question about the Minoan eruption has been settled. It has not. Scholars still debate wave heights, source mechanisms, and the extent of damage across the eastern Mediterranean. The significance is that the archaeological coastline keeps a physical record of volcanic water movement. Sand, shells, marine material, and erosional layers can preserve what written history may distort or forget. The wave becomes sediment. The sediment becomes evidence. Hold that thought, because Santorini's visible caldera is not the only volcanic source in the area. Northeast of Santorini lies the Colombo volcanic chain, including the submarine Colombo volcano. It is close enough to Santorini to matter, but hidden enough that most visitors never think about it. GMR reported in December 2024 that researchers set out to explore the Colombo volcanic chain to understand geological processes capable of triggering landslides, volcanic eruptions, and tsunamis, with the goal of improving early warning systems for coastal communities. That is a quiet sentence with serious implications. The danger is not only the volcano people can see, it is also the volcanic system below the waterline. Colombo has already entered the historical record. Scientific work on the submarine volcano notes that its 1650 eruption generated a destructive tsunami in the Aegean Sea. Researchers studying the source of that tsunami have emphasized the difficulty of volcanic tsunami attribution because several processes may be involved, including pyroclastic flows, underwater explosions, earthquakes, caldera movement, and flank instability. That uncertainty is not a gap in the story. It is the story. Volcanic tsunamis can be multi-cause events. This is why the Mediterranean warning cannot be reduced to fault lines alone. The basin contains active volcanoes, submerged volcanic fields, steep island slopes, unstable deposits, and coastlines close enough to receive a wave before distant observers fully understand what happened. A volcanic tsunami may not announce itself through the same pathway as a large offshore earthquake. It may begin with collapse. It may begin with a flow. It may begin beneath the surface. The blue water hides the machinery. Stromboli shows the flank. Santorini shows the caldera. Colombo shows the unseen source. Together they make one point difficult to avoid. In the Mediterranean, the most dangerous wave may not begin where people are looking. The sensors, watching the basin. The Mediterranean is watched from rooms without windows, not because the sea is hidden, but because the first evidence of a tsunami usually appears somewhere else. It appears as a vibration recorded deep inside a seismic network. It appears as a pressure change in a harbour gauge. It appears as a line of numbers travelling through a communication system before anyone on a beach can see the water behave differently. That is the modern warning system. Quiet rooms, monitors, clocks, operators, automated thresholds, data arriving from instruments scattered across countries that do not always share the same language, laws, coastline, or emergency culture. At the regional level, the system is known as NEMTS, the Tsunami Early Warning and Mitigation System for the northeastern Atlantic, the Mediterranean and connected seas. It was developed under the coordination of UNESCO's Intergovernmental Oceanographic Commission after the 2004 Indian Ocean tsunami exposed how catastrophic the absence of warning architecture could be. In the Mediterranean region, the warning structure depends on tsunami service providers that supply information to national warning focal points and national tsunami warning centres. Individual countries remain responsible for deciding what alert level applies to their own coastlines. That detail matters, because a scientific bulletin is not the same thing as an evacuation order. The basin now has 5 accredited tsunami service providers covering the region: IPMA in Portugal, Senalt in France, INGV in Italy, NOAA in Greece, and CORI in Turkey. Together, they form the upstream layer of the Mediterranean warning chain. They do not replace local civil protection. They feed it. Their task is to detect, assess, model, and transmit guidance quickly enough for national authorities to act. The first instrument is usually the seismometer. When a large earthquake occurs under the sea or near the coast, the warning centre must locate it and estimate its magnitude before the wave, if one has been generated, arrives. This is not a clean process. Early earthquake magnitudes can be revised. Depth estimates can shift. Fault geometry may not be obvious in the first minutes. A shallow earthquake of the right size in the wrong place can force a warning centre to act before the full scientific picture has settled. Italy's Cat Ingvi describes the threshold clearly. Within the Italian alert system, the centre assesses whether an earthquake of magnitude 5.5 or greater with an epicenter at sea or near the coast, may generate a tsunami and estimates wave arrival times along different coastal stretches. The number is not magic. It is an operational threshold, a way to force speed into a system where hesitation can become dangerous. But earthquakes are only the first layer. The sea itself must also be watched. Tide gauges and sea level stations measure changes at ports, harbours, and coastal sites. They can confirm that water has moved, record wave height, and help update or cancel alerts. In tsunami warning systems, sea level observations are transmitted through international data pathways, including the World Meteorological Organization's global telecommunication system, so that warning centres can compare seismic calculations with what the water is actually doing. That sounds complete until the timing is considered. A near-field tsunami may reach the closest coast before a tide gauge can provide useful confirmation. If the first sea level station is inside a protected harbour, it may not represent the strongest impact outside it. During the 2017 Bodrum Coast tsunami, a technical assessment noted that a tide gauge reading at Bodrum did not reflect the full extent of inundation along exposed coastal areas because the station was in a protected location. That detail becomes important later because a sensor can be accurate and still not describe the worst place. The Turkish system shows how much the region has changed and how much remains difficult. Kouri's Regional Earthquake and Tsunami Monitoring Center became operational as a candidate tsunami warning center for NEAM-TWS on July 1st, 2012, after preparatory work between 2009 and 2011. Its coverage includes the Eastern Mediterranean, the Aegean, the Marmara Sea, and the Black Sea. A review of Kouri's system describes achievements and lessons from tsunami-genic events including the July 20th, 2017 Bodrum Kos earthquake and the October 30th, 2020 Samos-Izmir earthquake, while also noting gaps that prevent a fully effective warning cycle. The French centre, CENALT, was built for the Western Mediterranean and Northeast Atlantic. Its objective has been described as transmitting warning messages in less than 15 minutes for events that could trigger a tsunami in its area of responsibility. 15 minutes is fast by institutional standards. In the Mediterranean, it can still be late by coastal standards. This is the uncomfortable part of the system. The sensors may work, the centre may issue the bulletin, the message may reach the national focal point, the local authority may activate the alert, and still, a near-source wave may already be approaching the first harbour. The weakness is not simply technological, it is structural. Every warning system has two halves. The upstream half belongs to science, seismometers, gauges, software, models, duty officers, message formats, and international protocols. The downstream half belongs to society. Sirens, phone alerts, police instructions, port closures, school drills, hotel staff, signs, roads, and public trust. The Mediterranean's upstream system has improved dramatically since the early 2000s. The downstream half remains uneven because it depends on every exposed community doing unglamorous work before the hazard becomes visible. That is why exercises matter. NEAMTES has run regional exercises such as NEAMWAVE to test message flows, institutional response and communication between warning providers, national focal points, and civil protection authorities. These exercises do not create headlines, but they expose timing problems that would otherwise remain hidden until a real event. The sensors are watching. That is true, but they are not watching alone, and they are not enough. A seismometer cannot clear a beach. A tide gauge cannot move a family uphill. A warning centre cannot guarantee that a tourist understands a siren in a language they do not speak. The instruments can compress uncertainty into a message. The coastline must turn that message into motion. The basin is being monitored more carefully than ever before. The question is whether the people standing at the water's edge are part of the system, or merely waiting for it to reach them, the drill that revealed the weakness. The most revealing moment in a tsunami exercise does not come when the alarm is sounded, it comes after. It comes in the pause between the official message and the first visible movement of people. The siren may work, the bulletin may be transmitted, the route may be marked, the emergency plan may exist in a binder, a municipal server, and a civil protection office. But for a few seconds, sometimes longer, the coastline waits to see whether anyone understands what they are supposed to do. That pause is the weakness. Across the northeastern Atlantic, the Mediterranean, and connected seas, tsunami exercises are not symbolic performances. They are the closest authorities can come to placing the system under stress without waiting for a real wave. UNESCO's Intergovernmental Oceanographic Commission describes these exercises as ways to test communications, review agency procedures, maintain operational readiness, and promote preparedness precisely because tsunamis are infrequent. Infrequent hazards are dangerous in a special way. They give institutions enough time to improve, but they give the public enough time to forget. The Neem wave exercises were built for this problem. They simulate earthquake-driven tsunami scenarios, message dissemination by tsunami service providers, and the actions of national warning focal points, national tsunami warning centres, and civil protection authorities after those messages are received. Since the first regional exercises, they have been conducted regularly, usually every 2 years. Their purpose is not to prove that the system is perfect, it is to expose where the system slows down. Picture the exercise as it unfolds. A fictional earthquake is placed into the basin. It may be near the Hellenic Arc, off North Africa, in the Alboran Sea, or along another known hazard zone. The modelled seabed displacement produces a simulated wave. The warning provider sends its bulletin. National contacts receive it. Local authorities are expected to interpret it, decide what alert level applies, and activate whatever procedures have been written for their coast. Nothing physical has happened. No water has moved. Yet the drill has already become a test of whether hundreds of separate decisions can align quickly enough. That detail matters because the Mediterranean is not a single country with one emergency culture. The NEAM-TWS region covers 40 member states with access to the northeastern Atlantic and connected seas, including the Mediterranean, North, Baltic and Black Seas. Those states do not all have the same resources, warning channels, coastline types, tourist patterns, or public habits. A bulletin may move through a regional system, but the final response depends on local capacity. In November 2023, countries around the region prepared for a communication test and response exercise scheduled for November 6th and 7th. That kind of test sounds administrative, but administration is where many disaster failures begin. An unanswered contact number, an unclear message format, a delayed handoff, a municipal officer who does not know whether a bulletin means watch, advisory, warning, or evacuation. These are not dramatic failures. They're quiet failures. In a near-field tsunami, quiet failures cost minutes. The public-facing version of the drill is even more revealing. In a prepared town, people should know the evacuation routes before they are needed. UNESCO guidance emphasizes science-based inundation maps and community-developed evacuation maps and plans because a community is best prepared when it understands its own hazard and has already decided how to respond. A map made in an office is not enough. It has to become a route in the minds of people who live, work, and visit there. Cannes shows what that looks like when a city chooses to take the threat seriously. In January 2024, it became the first UNESCO IOC tsunami-ready community in mainland France and the northeastern Atlantic and Mediterranean region. The recognition followed work on warning procedures, evacuation mapping, signage, public information, and exercises along a coastline that includes beaches, the Old Port, marinas, festival spaces, and the Lerron Islands. The city did not become immune to water. It became harder for confusion to own the first minutes. Spain's Chipiona offers a different image. The town sits near Cadiz, in a region whose tsunami memory reaches back to the 1755 Lisbon earthquake. Modern reporting has described evacuation signs, sirens and drills conducted around November 1st, connecting public practice to a catastrophe that once moved through the Gulf of Cadiz. This is how historical memory becomes operational memory, not by telling people that a disaster happened once, but by making them walk the route they may need again. Yet even recognition has limits. UNESCO's Tsunami. Ready framework is performance-based, but official guidance is careful about what the label means. Recognition does not guarantee that a community will perform at a certain level during a real tsunami. That sentence should be read slowly. It means readiness is not a certificate hanging on a municipal wall. It is a condition that must be maintained through staffing, drills, signs, public awareness, funding, and repetition. The drill reveals the part of risk that hazard maps cannot fully measure. It reveals whether a siren can be heard over traffic. It reveals whether evacuation signs are blocked by parked vans. It reveals whether people instinctively move inland or stand near the sea to film. It reveals whether a hotel worker knows how to direct guests who speak another language. It reveals whether a school can leave quickly without waiting for parents. It reveals whether emergency vehicles can move while everyone else tries to drive away. These details are not secondary. They are the event before the event. By the time water is visible in the street, the warning system has already passed its decisive examination. The difference between a prepared coast and an unprepared coast may be hidden for decades, then exposed in 15 minutes. That is why the exercises matter more than the headline. A tsunami is not stopped by knowing that it is inevitable. It is survived by making the first human response faster than doubt. The Mediterranean has the sensors, it has the warning centres, it has the history. The drill asks the remaining question: when the message arrives, will the coast move? The day, the water, finally comes. The day will not begin with a headline, it will begin with the sea looking normal. A ferry will leave harbour on schedule. Hotel workers will open shutters toward the water. A fisherman will check a rope that has been checked 1,000 times before. Somewhere along the Mediterranean edge, a city will enter an ordinary morning without knowing that beneath the basin, or along one of its volcanic slopes, the first movement has already happened. The warning will not be poetic, it will be technical. A seismometer will register rupture. A centre will calculate magnitude, depth, and location. A sea level station may begin transmitting abnormal data through international systems used for tsunami warning. Within the regional framework, the Northeastern Atlantic, Mediterranean and Connected Seas system exists, so that information can move from monitoring centres to national authorities. But the public will never see most of that chain. They will see the last part only. A siren, a phone alert, a police vehicle, a harbour order, a voice on a loudspeaker, or perhaps nothing at all if the source is too close. UNESCO IOC's regional programme states the underlying risk plainly. There is a 100% chance of a tsunami of at least 1 metre in the Mediterranean within the next 30 to 50 years. The sentence sounds statistical until it becomes local. That is the central truth of this story. The Mediterranean tsunami is not inevitable because one exact fault has chosen one exact day. It is inevitable because the basin contains the ingredients: active faults, volcanic islands, submarine slopes, historic tsunami records, dense coastal populations, ports built on low ground, tourist districts built for access, not escape. A warning system can reduce the risk, but it cannot remove the water from the map. When the day comes, the first places to face the real test may not be the most famous. It may be a small port where the harbour wall funnels current. It may be a beach town where evacuation signs are hidden behind seasonal advertising. It may be a marina where owners hesitate because they think they can save a boat. It may be a city that has mapped the hazard, but never made the public walk the route. That detail matters. Disaster does not only expose natural forces, it exposes administrative habits. UNESCO's Tsunami Ready Recognition Programme is built around that problem. It aims to strengthen communities through preparedness, awareness, evacuation planning, signage, exercises, and local risk reduction, with the stated goal of protecting life, livelihoods, and property. The programme also reflects a larger ambition announced by UNESCO to make 100% of at-risk coastal communities tsunami ready by 2030. That date is not a scientific deadline, it is a preparedness deadline. It says that waiting for the wave is no longer a reasonable strategy. The difficult part is that preparation often looks unnecessary until the moment it is too late to build. A sign can appear excessive on a calm promenade. A drill can feel theatrical on a sunny beach. A hotel evacuation plan can seem like paperwork. A harbour exercise can irritate people who believe the sea has always been manageable. But the entire purpose of preparedness is to create memory before fear arrives. When the water is already moving through streets, there is no time left to teach the route. This is where the Mediterranean differs from the oceanic disasters that shaped modern warning systems. The Pacific can offer hours in some scenarios. The Indian Ocean catastrophe of 2004 revealed the horror of a basin without adequate warning and public readiness. The Mediterranean, however, may offer minutes. In the Alboran Sea, in the Aegean, around Sicily and Calabria, near volcanic islands, or beside unstable submarine slopes, the distance between source and shore may be brutally short. A perfect bulletin that arrives after the first wave is no longer a warning, it is a record. The warning centres understand this. Tsunami bulletins for the Mediterranean and Northeast Atlantic region are provided by service providers in France, Greece, Italy, and Turkey, with national authorities responsible for the actions that follow. That structure is necessary because coastlines are governed locally, but it also means the final response depends on coordination between institutions that must move faster than the sea. The sensors are better than they once were, seismic networks are faster, sea level data can be shared through international communications pathways, regional exercises test whether messages move correctly from one authority to another, but no instrument can solve the final human problem. A tide gauge cannot make a tourist trust a sign. A seismometer cannot stop traffic from jamming the coastal road. A warning centre cannot force a crowded waterfront to choose higher ground over curiosity. The last mile of tsunami warning is not technological, it is behavioural, and yet this is not a story about helplessness. The evidence points in the opposite direction. Communities that map inundation zones, place visible signs, conduct drills, educate schools, prepare hotels, train port staff, and repeat the message before the emergency are not pretending they can stop a tsunami. They are shortening hesitation. They are converting a scientific warning into a public reflex. In a near-field event, that conversion may be the difference between survival and disaster. So the final image is not a wall of water. It is a staircase marked clearly from the promenade. It is a teacher who does not wait for a second alert. It is a harbour master who orders people away from boats. It is a hotel worker who knows the route uphill. It is a family that hears the siren and moves instead of filming the sea. It is a city that has already rehearsed the moment that everyone hopes will never come. The Mediterranean will continue to look calm. It will keep reflecting sunlight against old stone, carrying ferries between islands, filling postcards, and convincing millions of people that beauty and safety are the same thing. They are not. The sea can be beautiful and dangerous at once. That is not a contradiction. It is the condition coastal civilization has always lived with. The wave may come in 30 years. It may come sooner. It may be small enough to become a warning, or large enough to become history. The exact day is unknown. The obligation is not. The Mediterranean has already given its evidence. The question now is whether its cities will answer before the water does. The Mediterranean will keep looking calm. That is the danger. The next tsunami may not look like a disaster film, and it may not need to be the biggest wave in history. It only has to arrive faster than people can react. Lisbon proved it. Messina proved it. Nice proved it. And UNESCO is warning that the next one is not a question of if, but when. So if this video changed how you see the sea, subscribe for more deep investigations into the disasters hiding in plain sight, and watch the next video, because the next warning may be even harder to ignore.